So we are finally ready to start this little, very short, now 5 minutes short to talk about new features in the strace. I'm Dmitry. I'm a maintainer of strace for quite some time, and today I'll give a short talk about new features, just a few of them, because, well, most of stuff we're doing is quite boring and nothing to talk about, but very important for these features and other new features to work. But if you're really curious, you can have a look at release notes and dig out all the boring stuff is there. But today I'll remind you about fault injection I was talking about last year, and we'll talk about new features. Some of them are already included and already released, and some are still being merged. So this is a recollection from the last year. Fault injection. If you just happen to miss this new feature, it's very unusual for traditional strace that you can tamper with system calls, like in this simple example, or where you actually can inject any kind of fault in any system call you specify, like in those invocations you want. And this is also from last year's talk. It's a real bug was found in Python. It's already fixed now, but you can see that it just failed to check return code from OpenSyscall and from resyscall, and that resulted to sig faults because then just accessed and fixed offset from a null pointer. Another bug was fixed in dynamic linker in glibc. Pretty harmless bug, but still it was a bug. It was ignored setting protection. Some portion of memory expected to be inaccessible, but it failed to check this, and it remained accessible. This is not good, but it was fixed also. So this is just a quick recollection from the last year's talk. If you are more interested, you can just have a look at it and play with it. It's a very useful feature. You can use it for like regression testing. We actually use it in test suite of strace itself. So you're welcome. And we implemented more features in this direction. So there is a new option called inject that can inject not just faults to syscalls, but other kinds of things like signals to syscall invocations, other kinds of return codes that are not that useful, and also delay injection. This is a quite new feature. It's not yet merged. That you can inject delays in invocations on entering syscall, on exiting syscalls, and like if a strace wasn't slow enough, you can make it even slower in specific cases. As you can see in this example, like how orders of magnitude is slow? 1, 2, like 3 orders of magnitude slower, just those specific syscalls you want to. Besides this, silly examples where you can also, well, silly, I actually been asked several times that people wanted to slow down some syscalls to throttle network traffic, for example, and those tools that don't implement this, like slow down reads or sends or some other syscalls. Another kind of use for this feature is like in fault injection case is for regression testing, where you can specifically slow down some process that's expected to complete some operation very fast. And if another process or thread is waiting for it for a fixed time, this will fail. So this way you can do that kind of inject some delays that affect control flow. Let's do this. My talk consists of small blocks, and if you have questions, when you see this thing like 5/5, it's the end of block, and you can ask them right now if you want. If not, let's move on to another block. So this year, actually last 2 years, we've been a project It was a Google Summer of Code GSOC project of 2 years that implemented parser for netlink traffic. The first year was very groundwork, and last year we implemented the most popular netlink protocols, starting with route, and you can see like 9 of them, and more are going to be implemented this year, I think, hopefully. How does it look? This is a very simple routing table. To make this routing table, you have to create like a basic container with no network interfaces, just a loopback interface. If you create this, you will have just 4 kernel routes. So how does it actually look? What IP tool sees from the kernel? This is going to be a very impressive picture. Be prepared. That's what's going under the hood. You see, this is a very structured output. I did some coloring. It's manual, sorry. I did it by hand. So, but you can see that, I mean, the tool, it doesn't see any colors. It sees structures. Sorry.
You should have shown the old output first, the binary. No, from strace without the disassembly.
Oh, sorry. It's just very simple. You will see syscalls, but without all these structures, it will be just string or pointer, depending on what kind of. As you know, with CentOO, it would be instead of this structure that starts here, yeah, with curly brackets, you would see. Oops, sorry. You would see just in all the traces, you would see just a string, a binary string that means nothing. But here you see like a structured output almost. No, this is a netlink route, but are also supported. You can see on this 9 of them. So it's almost like a netlink debugger, without probably. You can't really inject all this stuff inside the program, but you can see all this gory details. So then let's go on. Another set of features we implemented is related to syscall specifications. Strace, as you probably know, have a lot of filtering. Like it can filter syscalls by classes. This time we decided to add some more classes, but to avoid collisions with system calls, we added prefix. So all new system call classes are started with prefix %, and all traditional system call classes are also have this prefix. So these are traditional, and we also did like 4 different stat family syscalls. You can see in this example how it looks like. What does it mean 2%? Just the way to describe all stat process family syscalls. Why so many? How many fstat system calls do we have in Linux kernel, do you think?
4, 6.
5. Why 5? Well, 64-bit architectures usually have 2 of them. 32 bits also 2, but different. And there is also an engine system call that modern architectures don't have. But you don't have to worry about all these details. Just use the system call class name. That's all, as you can see in this example. On the 27th year of the project, we decided. We found out that we don't still have support for regular expressions. How could that be? So we did this, and you can see that the same example from the previous slide could be like using. You can do the same thing using regular expressions. I don't think it looks easier to use, but with regular expressions you can do all different things. Oh, thank you. The time is going back. Another feature of system call specifications is conditional expressions. As you probably know, system calls are added like every or almost every new Linux kernel release, and they are not added to all architectures at the same time. It's not normally the case. For example, the recent from a stat family called statx, it was added for many architectures but not for all. And if, for example, you write a somewhat portable script using a strace, you will get into the situation that it works in most cases, but doesn't work on more niche architectures like Itanium, where statx up to this point is not yet right up. So using this conditional specification, you can work around this. And this is a real case example. You will probably seen this or will see in the future that GNU-libc switched from open to openet internally, and also for implementing open library call. So if you used to trace by open, it no longer works starting with libc 2.26. But if you switch to openet, you won't be able to trace all the glibcs. It's not good. So you can use the list, but it's not portable because open is not available on some architectures. So how you can write a portable strace script? You can use a regular expression or you can use a condition. So there are two examples. Which one is easy to read, do you think? A regular expression or condition? I think condition. That's why we added condition, despite that with regular expressions you can describe the same thing, but it's usually looks more complex. Yes?
I don't understand the condition. So
it says that this syscall specification doesn't happen to match any real system call. So you can write foobar, and strace will not trace any foobar because there is no foobar syscall.
And otherwise your regular expression would be invalid.
Yeah, if you just type a syscall or regular expression that doesn't match any syscall, a strace will not run, it will issue an error, as you can see. Yes, sorry?
Why not make it a default? Why not make a condition a default?
Why not make a condition a default behavior was the question. First of all, you won't detect any accidental errors. People do errors sometimes. And it will be a change of behavior. And for a project of 26 or 27-year-old, it's not a good idea actually to change behavior in a backward incompatible way for not really good reason. Okay, the last topic is advanced syscall filtering syntax. This was implemented also as a part of Google Summer of Code project last year, and it allows even more flexible specification of syscalls. For example, you can trace by file description number with traditional syntax. You can just either trace by specification, as you can see, or could see before, or you can dump by file description number. Now you can combine all these things. You can combine actions. Default is trace. You don't have to specify it. It's written here, trace, but you can omit it, as you can see on following slides. You can also combine different kind of things, like you can, as you can see in this example, you can trace read syscall and dump only those syscalls that access a specific file. This way you will see that in slightly artificial example, you can see that some program accesses different things, but we dump only those of them that are actually interesting. Why dumping dev0 could be interesting, I think? Well, I've seen once it was not a device but a file, in real life, it was not a good idea to replace a div0 with a file. I think somebody just with a super-user privileges redirected output there, and did something like this stupid thing. And well, you can use logical expressions like and, not, brackets. This way you can do very flexible filtering. As you can see, you can select only those syscalls that work with files but doesn't take descriptors as arguments and doesn't return descriptors as their return value. Or you can, all kinds of combinations, logical expressions. As you can see in these examples, in the first example, you don't see anything, just as you could expect, cat works with the file, it opens it, it does something with it, but you don't see all these syscalls, only those that are specified. This is another example of that kind of combination you can use. Like before this, you couldn't specify what kind of syscalls you want to stack trace. So all syscalls in traditional syntax, all syscalls selected for tracing would be stack traced if you request it. Now you can select which of those syscalls that are traced are actually stack traced. So you can see this program accesses descriptor number 1, but we're interested only in those close syscall to have a look where it goes from. As you can see, it's from exit handler. So what cat probably does, it installs an exit handler that closes standard output, and it's actually what's happening, as you can see in this example. So that's more or less all. Who is this, do you think? This is a mascot. A strace up to last year had no mascot. So we're very happy that we have one. Meet our new mascot. If you have any questions. Yes, please.
Why should you prefer to filter out things in strace instead of using external tools such as...
So the question was why one might want to filter something in a strace rather than parse a strace output, right? Well, tracing makes things slow. If you don't need something, then you don't trace it. You don't parse all this. Imagine how many syscalls you have to issue to fetch all this memory from tracing. If you don't need this, you just don't. That's why. Yes, please. Yes. It's not really netlink tracing. It's advanced parsing of the traffic that goes. Because by default, if it's treated as a string, it means nothing or almost nothing. It's a parsing. It's not additional tracing capability, it's additional parsing of things. So the syscalls are the same. Or it could be any kind of syscall, it could be just read, right? Yes, please.
Do you already have this parsing or maybe blended parsing, for example, for DNS requests and other things, which are sometimes very helpful to understand the strace?
We don't have parser for DNS protocols, and I'm not sure because it's not something you can distinguish from a socket. For example, when this socket is a netting socket, you can find this out.
Distinguished by port, so at least I could filter by port and say make that trace filter whatever. It would be a nice feature. Now I see that it's really impressive, and having some more binary blobs getting a bit more verbose would be a great thing.
So it probably would make sense to implement some kind of plugin system to someone would just implement a parser for this chunk of memory. A strace would fetch it and give to a plugin to
which port with destination, whatever, use which filter and things like that.
sorry.
And then have a set of rules from tracing something, that port, that destination, that system call something, use this plugin for analyzing code.
Yep,
And
for example.
UDP data, it's easy.
Usually replacing something what Wireshark already does. So I can imagine just outputting the.
Yeah, but it's on a different level.
binary blobs.
Sometimes it's difficult with Wireshark.
It's not really a Wireshark. It's a strace.
It's S-trace. Yeah, there are good reasons sometimes using S-trace for a complex problem, and you only want to see what's going on the network before your make, for example, does weird things.
Yeah,
Yeah, it's not about
output the
network in the first
binary blobs from strace and then put it as an input to the Wireshark. Which already has this. Like,
Yes, this also could make sense. Yeah.
Okay, yeah.
So you will
Yeah, thank you.
Getting the effort on the strace.
Don't reinvent the wheel, just make an interface to export CAD
okay,
files.
Yeah.
Just having, but I want to have the feature in S-trace finally. Just get this wonderful output for. Oh, you're asking for DNS host, but resolving something like that.
Yeah, this makes sense. Not to replicate all this work making Wireshark and TCP dump and whatever else. Yeah. Any more questions?
What's the mascot's name?
We can choose something for a name.
Noise switch on in?
Yes, I think it's Charles. Yes. He's nice, isn't it? Any more questions? No? Then thank you.